Hello children, welcome back to my channel. I am now dealing with 10th class maths probability. In the earlier video, I have do this up to A, B bits, and now I am doing C bit. C bit is give examples of 5 experiments that have equally likely outcomes and 5 that do not have equally likely outcomes. So I have written both here, equally likely outcomes and not equally likely outcomes. So let me explain you one by one here. See, first one, getting head or tail when a coin is tossed. So explanation I am giving here, children. The first one, getting head or tail when a coin is tossed means the chances are only two. Chances when you take head has got one chance and tail has got one chance only. So it is equally likely outcome. And the second one is getting an even or odd number when a die is rolled. So when a die is rolled, what are the die numbers you have got? It starts with 1. So 1, 2, 3, 4, 5, 6 numbers are there. In this even or odd, see what are even numbers? 1, 2, 3. So we have got 3 even and 3 odd numbers. So both of them are equal in number. So they are equally likely terms. And the third one, selecting white or red balls from a bag of 4 red balls and 4 white balls. So number of red balls and white balls. Red balls are 4, white balls are also 4. So since their number is equal, they are equally likely outcomes. And fourth one, selecting a red or black card from a deck of cards. Deck of cards means you are having 52 cards already altogether. In that, we have got ace, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then jack, 12, king, jack, king, queen. So total A is considered as 1. A, 2, 3, 4, 5, 6, 7, 8, 9, 10. Deck of cards, we have got A to 10 and then jack, king, queen. So what are the total? 13 cards. 13 into 4 types are there. 52 cards totally they are having. Each one is having 13, 13, 13. Equally likely outcomes, children. Red or black cards, if you talk about, they are each red color, two will be there, that is heart shape and diamond shape, and black color two, which are spade and club. So all those are, we can see diamond shaped ones will be there, and heart shape, these are red, and club, this is club, and this is spade, this is club. These are all, these two are black. So each one, this will be 13, this will be 13, this will be 13, 13. So totally 52 cards are there. So each one is having same number. So we can say that red, these are also equally outcomes. And fifth one, selecting winning or losing a game. Winning has got one chance and losing is also one chance. They may win or they may lose. So these are also equal. So they are also equally likely outcomes. The next one, not equally outcomes. Not equally likely outcomes. Getting a prime or composite number when a die is rolled. First one, die 1, 2, 3, 4, 5, 6. getting a prime or composite numbers. What are prime numbers here, children? 2, 3, 5. Okay, these are all prime numbers. And composite number. What are composite numbers? One is neither prime nor composite. So here you are having prime numbers 3 and composite numbers you have only 2. So see, they are not same. One is 3, one is 2. This number 1 is neither a prime nor a composite, so we cannot take. So in this, prime numbers are 3, composite numbers are 2. So it is not equally likely outcome. Then the second one is selecting a white or red balls from a bag of 5 red balls and 10 white balls. So red balls are 5 and white balls are 10. So these two are not equal in number, so they are not equally likely outcomes. And third one, selecting a picture card from a pack of 5 picture cards and 10 number cards. So picture cards are 5 and number cards are 7. So these are also not equal in number, so they are also not equally likely outcomes. And when you talk about the fourth one, in this fourth one, selecting a marble from a bag of 5 marbles and 7 glass balls. So marbles are 5. Marbles are 5 and glass balls are how many? From a bag of 5 marbles, 7. Okay, here also the numbers are different, so they are also not equally likely outcomes. Seventh one, selecting an even number card from a pack of 1 to 9 cards. So when you write 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers, in this even numbers are, see, 1, 2, 3, 4. So even numbers are 4 and odd numbers, how many are there? 1, 2, 3, 4, 5. Odd numbers are 5. These are also not same, so they are not equally likely outcomes. So in fact, what are we understanding with these children? Equally outcomes should have same number of outcomes. Chances should be same, then they are called equally likely outcomes. And not equally likely outcomes means the chances will be different, one is less, one is more, so they are not equally likely outcomes. Please go through it, children. Now example 1, children, find probability of getting head when a coin is tossed. Also find the probability of getting tail. So here, let us write a sample space for the problem, children. Sample space, yes, is nothing but tail or head. These are the two chances. So n of s, number of elements here are 2. Therefore, number of possible outcomes, how many are there? 2. And we want probability of getting head. Probability of getting head we are going to talk about. Here this means what are there is only one chance here. So here number of favorable outcomes. Favorable outcomes is equal to 1. Therefore, P of E. P of E means probability of the event, which is nothing but number of, we have already learned this formula, children, number of favorable outcomes by number of possible outcomes. So this is the answer for the first bit, number probability of getting head. Similarly, probability of getting tail. Here also, for probability of getting tail, number of favorable outcomes, are one only. So, therefore, probability of this event is also nothing but 1 by 2. This is the answer. So, see children, here there are only two, that is sample space already. See, this is the same procedure which we are going to do in each and every problem of this probabilities. It's a very simple one. If you understand the basic of how you need to do the problem, any problem you can solve by yourself. So first we have to write sample space. What is sample space means? What is the problem dealing with? The problem is dealing with tossing a coin. A coin, when you toss, there are only two chances, tail or head. So, sample space is nothing but tail or head. So, number of elements in this sample space will be 2. This 2 becomes a possible outcomes, a number of possible outcomes. Now, the problem is probability of getting head. So, number of favorable, here head is only 1. So, number of favorable outcomes are 1. So what is probability of the event? What is the event? Getting head. That is nothing but 1 by 2. Similarly, we are getting probability of getting tail as 1 by 2. Please note it down. Example 1. Example 2 is like this, children. A bag contains a red ball, a blue ball, and an yellow ball. All the balls being of the same size, Manasa takes out a ball from a bag without looking into it. What is the probability that she takes yellow ball, red ball, or blue ball? So, first one, what is the sample space? Sample space here, what does the problem is dealing with? It is dealing with a red ball, a red ball, blue ball, and yellow ball. So this is the sample space. That means what is n of s, children? 1, 2, 3. It is 3. So the first bit is you have to talk about yellow ball. Yellow ball means here a number of favorable outcomes. How many are there? There is only one. Why? Because yellow ball is only one. So therefore, probability of this event is nothing but 1 by 3. And second one is we need to talk about red ball. Even this also, number of favorable outcomes is 1. Therefore, P of E is also 1 by 3. Third one, you have to talk about red, blue, and yellow. So, blue ball. Here also, number of favorable outcomes is 1. Therefore, P of E is equal to 1 by 3. So, see children, always we need to know first if you write sample space, whatever is the problem, accordingly we can do. See, in this problem, we have only 1, 1, 1. So, here we don't get any sample space. Otherwise, if the number is more, definitely we will get a sample space here also. So, the main problem is how you have to do, how many number of what is the problem dealing with and what are the elements that are there in the problem. When you write, you will be getting number of samples, number of n of s is 3 means what you can say, this is nothing but number of possible outcomes. Number of possible outcomes are 3. So we know that probability of event is number of favorable outcomes by number of possible outcomes. When you are talking about yellow ball, there is only one. So probability of the event will be 1 by 3. So favorable outcomes are 1 by 3. Similarly, red ball is 1 by 3 and blue ball also is 1 by 3. Please note it down, children. Example 2. Now, the next one is example 3, children. Suppose we throw a dice once. First question, what is the probability of getting number greater than 7? Probability of getting a number greater than 7. Greater than 4. This is the question, children. Probability of getting a number greater than 4. For this, first you write what is sample space. Sample space means what does it contain, children? When you are throwing a dice, you have got chances 1, 2, 3, 4, 5, 6. Any number can come out when you are throwing a dice. That means n of s is how many? 6 numbers. So number of possible outcomes. Possible outcomes are 6. Now, probability of getting greater than 4. So, number greater than 4. That greater than 4. This is the question. Number greater than 4. For this, let us write sample space. What is sample space? Greater than 4 means 5 and 6. So, n of s here is 2. So, number of favorable outcomes. How many? 2. Therefore, probability of the event that is asked. What is the event? Probability of getting a number greater than 4. So, this is nothing but favorable outcomes. Number of favorable outcomes by number of possible outcomes. 2 ones are 2 threes are. 1 by 3 is the answer for the first bit, children. So, let us go for the second bit. What is the second bit? What is the probability of getting a number greater than or equal to 4? Probability of getting a number less than or equal to 4. So this is lesser than. Less than or equal to 4. So here, if you write sample space, what is the sample space here? See, total possible outcomes are this. Less than or equal to 4 means right from 4 lesser values. 1, 2, 3, 4 you have to write. So this is nothing but 1, 2, 3, 4. That means n of s here is 4. So what is this for? Number of favorable outcomes. Number of favorable outcomes are 4. So what is the probability of event? Number of favorable outcomes by number of possible outcomes. We have written here 6. So 2 2s are 2 3s are 2 by 3. This is one answer, children. These are the 2 bits that they have asked. Very simple chapter, children. It's very easy for you to do it. understand the concept very easily. They have thrown a dice once. So dice, when they have thrown two bits that they have asked is probability of getting a number greater than 4 or probability of getting a number less than or equal to 4. So first bit when we answer, before answer this first bit itself, we have to write the sample space. What is sample space? What all the possibilities that we will be getting when a die is thrown. So it may be 1 or 2 or 3 or 4 or 5 or 6. That means there are number of sample spaces are 6. That means what? Possible outcomes are 6. And number greater than 4 when we are talking about, this is 4. Greater than 4 we have only 2 numbers. So for that also we have to write sample space. In the earlier problem I told you when I was teaching that there is only one item, so directly I have written number of favorable outcomes. But for this problem it's not one, so we need to write sample space even for it also. So the sample space is 5, 6. That means you have got only 2 number of sample spaces. That means favorable outcomes are 2. So probability of the event. What is the event? Event is probability of getting greater than 4. A number greater than 4. That is 2 by 6. Favorable outcomes by possible outcomes. That is 1 by 3 is the answer, children. Next, probability of getting a number less than 4 or equal to 4. So when you write the sample space, say the main possible outcomes sample space. Here 4 or less than 4. So 4 is included. So 1, 2, 3, 4. These all are sample spaces only. That is 1, 2, 3, 4. That means n of s is 4. So number of favorable outcomes are 4. Probability of the event. What is event? Getting a number less than or equal to 4. That is 4 by 6. 6 is this. So 2 by 3 is the answer. Please note it down, children. Now, example 4, children. One card is drawn from a well-shuffled deck of 52 cards. Calculate the probability of getting that card will be an ace or not an ace. So, I hope you all know, you might have seen cards, playing cards. Playing cards will be having 4 different shapes with the 2 colors. So, when you take diamond and when you take heart, these 2 shapes are red in color. And a spade, when you take a spade, this is the shape of a spade, and a club, this is a club. These 2 are black in color. So each one is having 13. That means we will be having ace 1, ace is 1 is considered as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and a jack, a queen, a king. Total how many children? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Total each one 13 cards. This is 13, this is 13, this is 13, and this is 13. So total how many? 13. Total 13 into 4, 52 cards will be there. This is only an explanation, children, for you, so that you will understand this cards color and their shapes. So now the problem is, the first bit is, what is that they are asking to be an ace. We want an ace. So what is the first sample space? Let us write, children. Sample space, you have got how many total? 52 cards. That means sample space here we will talk about n of s. That is 52. Why? Because if I write a lengthy one, I'll get, I have already explained you to your children. Sample space contains 52 cards. Now in this 52 cards will be number of possible outcomes. Number of possible outcomes is equal to 52. Now for A's, let me write sample space. What is the sample space for A's? You are having a diamond ace and a heart ace, and you have got a spade ace, and you have got a club ace. So many aces will be there. That means what is n of s? N of s is 1, 2, 3, 4. So number of favorable outcomes. Number of favorable outcomes are 4. So what is the probability of the event? That is number of favorable outcomes by number of possible outcomes. 4 ones are 4 threes are 1 by 13 is the answer for this problem, children. Probability of getting that card be an ace is 1 by 13. And the second problem, second bit is not be an ace. Not be an ace. So here number of favorable outcomes will be from 52. Aces are 4. Already we have done here. Number of aces, all these are 4 aces. So if you subtract that, the number 48 will be the favorable outcomes. The total 52 cards are there, children. I have explained how the 52 number has come. In that, not be an ace means aces they should not remove. So if they should not remove aces means there are 4 possibilities of getting aces. So that 4 I have removed. So 52 minus 4 is 48. Number of favorable outcomes are 48. So number of favorable outcomes are 48 means probability of the event is what? Number of favorable outcomes by number of possible outcomes. So 4 ones are 4 twos are 4 ones are 4 threes are 12 by 13 is the answer for this problem, children. So please note it down. Once again I'll explain. See, a card is drawn from a deck of cards. Deck of cards I have already explained here, children. Deck of cards contain two red shapes. That is, one is diamond and one is heart shaped cards. 13 are there. How are the 13? See, I have written ace to 10. 10 cards, jack, queen, k. So total 13 cards are there. 13 cards here, 13 cards in this, and this is spade, this is club. Spades are 13, clubs are 13. So totally 52 cards are there. So first question is, what is the probability of getting an ace, be an ace, the card be an ace? So for this sample space, so for the entire problem we need sample space. Sample space is 52, children. That is n of s is 52. So possibilities are 52. Possible outcomes are 52. And what is ace? Sample spaces? See, diamond ace, heart ace, spade ace, club ace. So total 1, 2, 3, 4. Number of the n of s is 4. That means what is this n of s? Favorable outcomes are 4. So probability of getting this event, what is that event? BNS is 4 by 52, that is 1 by 30. Now the second one, not BNS, means here favorable outcomes will be from the total cards you are removing 4 cards which are A's. Already we have taken. So that is 48. So this is nothing but favorable outcomes. So probability of event is 48 by 54, that 52, that is 12 by 13 is the answer, children. This is example 4. Now example 5, children. Sangeeta and Reshma play a tennis match. It is known that The probability of Sangeeta winning the match is 0.62. What is the probability of Reshma winning the match? So, probability of Sangeeta winning the match is, how much they have given? 0.62. That means P of E is equal to 0.62. Now, probability of Reshma winning the match. Winning the match is nothing but it is P of E dash. So we know that P of E plus P of E dash is equal to 1. I already explained you about complementary probabilities, children. In that I said the sum of these two is equal to 1. This is 0.62 plus probability of E dash is equal to 1. So what is probability of E dash? 1 minus 0.62. So 1 minus 0.62. Keep zeros here also. So 8 you will be getting, 3 you will be getting. So 0.38. 0.38 is the answer. The probability of getting Reshma winning the match is 0.38. These are all the problems basing on the complementary probabilities, children, which I have earlier when I was dealing with the first video. I have explained you about that. If you have any doubt, you can go through that video. Here, the problem is dealing with the two girls, Sangeeta and Reshma. Probability of Sangeeta winning the game they have given, that is to be considered as probability of event. They are asking probability of getting winning Reshma, that becomes a probability of E dash. So we know that these two complementary angles will complementary probabilities will give you the answer as one only. So on calculating, I have got P of E dash is equal to 0.38. P of E dash means probability of winning Reshma is P of E dash is 0.38. Please note it down, children. Example 6, children. Sharada, example 6. It is Sharada and Himada. It goes on like this. Let me read. Sharada and Himada are friends. What is the probability of both will have different birthdays and same birthdays? So, first one, let us talk about different birthdays. First, let us talk about sample space. What is sample space will tell you it is nothing but number of days in 1 year. See here, children, they have already given that ignore leap year. When you ignore leap year, n of s will be 365 days. So, different birthdays means the Sarada's birthday for Sarada's birthday, n of s will be 1, children. Any one day she will be having birthday. Out of 365 days, one day will be her birthday. So, probability of event is nothing but 1 by 365. Because she has any one day out of 365 days, her birthday. Then, same different birthdays means, what is Himada's birthday? Himada's birthday, Himada's, for Himada's birthday, what is n of s? number of sample spaces. See, total 365 days are there. In that, one day has gone, but for Sarada's birthday, and that day definitely Himada's birthday is not there. That means 364 days. 364 is her N of S. That means number of favorable outcomes is equal to 364. So, what is P of E here? That is probability of getting Himada's birthday, 364 out of 365. This is the answer for that problem. This is probability of getting same birthday. Here, the Sarada will get 1 by 365 chances, and Himada will get 364 by 365 chances, children. This is about the first bit. And second bit, same birthday. So second bit, what is the second bit? The second bit is they have same birthday. So same birthday means actually it can be considered as P of E dash. P of E dash, because different birthdays already we have got. So same birthday means P of E dash. We know that P of E plus P of E dash is equal to 1. Here P of E should be considered as 364 by 365, because different birthdays probability is 364 by 365 plus P of E dash is equal to 1. So P of E dash is equal to 1 minus 364 by 365, that is 365 minus 364, that is 1 by 365 is the answer, children. So problem looks difficult, but when you do, it's very simple, children. Sarada and Himada, both of them are friends, and they are having, the question is, what is the probability that they will be having same birthday, different birthdays? What is the probability that they have same birthday? So here, for different birthdays, sample space is nothing but a number of days in 1 year, that is 365. N of S is 365. So what is this N of S? Number of possible, I have forgot to write, children, please bear, possible outcomes. Number of possible outcomes is 365. Now, Sarada's birthday, when you talk about, Sarada's birthday is only 1 day out of 365. So, her probability is nothing but 1 by 365. Now, Himada's birthday should be different than that of Sarada's birthday. So, that means out of 365 days, 1 day has gone for Sarada's birthday. So, the remaining days are 364. So, number of favorable outcomes are 364. So, probability of event is 364 by 365. So, total number of different birthdays will be 364 by 365. Now, same birthday will be, it is considered as probability of not event, because there is a possibility of either they get different birthdays or same birthdays. So these two are complementary to each other. So P of E plus P of E dash will be equal to 1. P of E is 364 by 365 plus P of E dash is equal to 1. So P of E dash is 1 minus 364 by 365. 1 by 365 is the answer, children. Please note it down. There are, example 7, children, there are 40 students in class 10 of a school, of whom 25 are girls and 15 are boys. So, total number of students are 40, and number of girls, how many? There are 25 girls are there, and number of boys, it is given as 15 boys are there. The class teacher has to select one student as a class representative. She writes the name of each student on separate cards, the cards being identical. Then she puts the cards in a box and stirs them thoroughly. She then draws one card from the box. What is the probability that the name written on the card is the name of a girl or a boy? This is the question, children. So in this, what you need to find out, there are total 40 students are there in the class, and 25 girls are there, 15 boys are there. Out of these numbers, one should be the class representative. So what the teacher has done, she has written all the 25 names of girls, 15 names of boys in the same type of cards, and she shuffled them and she took out one name, one card. So in that, what is the probability of getting, the first bit is probability of getting a girl. Probability of getting a girl. Probability of getting a girl means here what is the total students? Total students are 40. Therefore, n of s is equal to 40. What is this n of s? Number of possible outcomes. Outcomes is 40. Now, number of girls. We are talking about girls. So, number of girls, how many? 25. What is this? Number of favorable outcomes is equal to 25. So, what is probability of event? Event means number of getting girls. It is nothing but number of possible favorable outcomes by number of possible outcomes. So, 5 5s are 25, 5 8s are 40. 5 by 8 is a girl. Now, P of E is 5 by 8. Now, the next one is second bit, possibility of getting a boy. So, this means what? P of E dash is equal to how much? Because there is either a girl or a boy, they will be, and the card will give the name. So, P of E plus P of E dash is equal to 1. P of E we have got 5 by 8 plus P of E dash is equal to 1. So, what is P of E dash? 1 minus 5 by 8. That is 8 here. 8 minus 5, that is 3 by 8. Therefore, we'll be saying that probability of getting the name of a boy is equal to 3 by 8. So, this is one answer, children, and this is nothing but probability of getting the name of a girl is equal to 5 by 8. So this is one answer. This is 8, children. 5 by 8. This is one answer, and that 3 by 8 is one more answer, children. So let us see once again. There are 40 students in a class. Out of 40 students, 25 are girls and 15 are boys. What is the probability of getting a girl? So total number of students are 40, means n of s is 40. This is possible outcomes number. Number of possible outcomes are 40. Number of girls are 25. So favorable outcomes is 25. So what is probability of event? Number of favorable outcomes by number of possible outcomes, 25 by 40, that is 5 by 8. So probability of getting the name of a girl is 5 by 8. Now we want a boy. A boy means it is complement of a probability of event. So P of E dash is how much I have considered. So P of E plus P of E dash is 1. We know actually, so P of E we got as 5 by 8 plus P of E dash is 1. P of E dash is 1 minus 5 by 8, that is 3 by 8. So probability of getting the name of a boy is 3 by 8, children. Please note it down. So with this, I am concluding my part today. In the next class, I will be doing the next part.